So this video will go through volume of tapered solids and spheres. So that's looking at pyramids, cones and spheres, and also then hemispheres. And then we'll do some composite shapes involving those things. So we'll start with pyramids and cones. Now pyramids and cones have the same basic formula. There's just one part of it that changes. So the standard formula is 1/3 times the area of the base times the height of the pyramid. It's important that that height is the perpendicular height from the top of the pyramid to the middle of the base. If you're not given that height, you'll need to find it, and we will do an example like that. Now the reason that is 1/3 A times H, it's because it's 1/3 of the rectangular prism that surrounds it, or the prism that surrounds it. So our first example is a square-based pyramid. So we need to remember that A is the area of the base, and the base is the type of pyramid that it is. So you can see here in this example, the base is 2 centimetres by 2 centimetres, which means it's a square. So what we do is we would have volume is equal to 1/3 times the area of the base. Now the area of the base for this will be 2 times 2. So 2 squared, and then we multiply it by the height of the pyramid, which gives me 13.3 recurring centimetres cubed for this particular pyramid. The next one, if we have a look, it's very similar to the first. However, we're now looking at a rectangular based pyramid. So same sort of situation, but we know that for the area of the base, we still just do length times width this time. So we would have volume is equal to 1/3 times 11 times 4, because this part here is the area of the base, and then we multiply it by the height. Now, if you're not sure how to work out how to put 1/3 in your calculator as a fraction, on scientific calculators you press 1 and then the ABC button and then the 3, or for some of them there might be a fraction button available. Alternatively, you can do 11 times 4 times 12 and then divide the answer by 3. It gives you the same result. One just uses a fraction, whereas the other one does the division at the end. And this one here gives an answer of 176 millimetres cubed. Our next example is looking at a cone. Now, it is a special type of pyramid, and when we're doing 1/3 times the area of the base, we need to look at this particular pyramid now and realise that the base is now circular. So our formula for the volume of a cone is actually 1/3 pi r squared times the height, remembering that this pi r squared is the area of a circle. So to do this question, we would be doing 1/3 times pi times the radius, which is 5 squared, times 13. So if you needed to, you could go over here and put R and H on your diagram so it reminds you. It's also important to remember that if you're given the diameter, that you halve the diameter to get the radius before you even begin the volume. And the answer to this one is 340.3 millimetres cubed to 1 decimal place. Our next example is a different one, and it's one, if you have a look, we've been given the diameter of the cone, and we've also been given the slant height of the cone. They're two things that we can't use to find the volume, so we need to actually do some working out first. So straight away, we can actually work out that the radius would be 9 metres, but we also need to drop down this line here to find the height. Because remember, in the formula for pyramids, it has to be the height of the pyramid. So that is from the top to the middle of the base, which is what I've drawn there. And if you have a look, we now have a right angled triangle where we've got H, we've got 9 metres, and we've got 14 metres as our hypotenuse. So to find the height, we would do H squared is equal to 14 squared, take away 9 squared. which is 115, and then we need to do the square root to find the height, which is 10.7 meters to the 1 decimal place. So now that we have the radius and the height, we can use our volume formula, and we would do 1/3 times pi times 9 squared times 10.7. And we get 907.6 meters cubed to 1 decimal place. Now we'll move on to spheres and hemispheres. So the formula is different for a sphere compared to a pyramid, because obviously it's a different type of shape now, so we have to use a different formula. And the formula is 4/3 pi r cubed. And then, of course, a hemisphere is just half of that. So we'd calculate it and then we would divide it by 2. There's not really a set formula. We just divide our answer by 2. So our first one, we have this. We've got radius here, so that's good. We can start straight away. Again, remember, if we were given the diameter, you would have to find the radius first. So if we do volume, we would do 4/3 again on your calculator. 4 ABC3, or using the fraction button, or you can do 4 divided by 3 and then continue from there. So we'd have 4/3 times pi times 26 cubed. And for this particular sphere, we would have 73,622.2 meters cubed as our volume. And just for our hemisphere, now with our hemisphere, we've been given the diameter, so straight away we need to work out the radius, which would be 24 millimeters. And now we can start, so I'll just label that diameter so we remember. Then we do, the volume would be 4/3 times pi times 24 cubed. And then because it's a hemisphere, we're going to chuck the divide 2 on the end because we only want half of it. And once we've popped that into our calculator, you should get 28,952.9 millimeters cubed. And then lastly, we'll just look at a composite solid. We'll just look at one for this video because they basically have the same principle. It's a little bit easier to do composite solids with volume as opposed to surface area, because you don't have to think about what you can see and what you can't see, because we're looking at the inside of the shape this time. All you have to be able to identify what are the shapes that are involved. So you can see here, this shape, we've got a cone at the bottom and then a hemisphere on top. So we'd need to calculate both of the volumes. So we're going to do V1 and V2. So V1 is 4/3 times pi times 6 cubed divided by 2, because remember we're only doing a hemisphere. And to 1 decimal place we would get 452.4 millimeters cubed. Now we can do the volume 2. We check that we've got the radius and the height for the cone because that's what we need. It would be 1/3 times pi times the radius squared times the height. And to 1 decimal place, we would actually end up with 377.0 millimeters cubed. And then, of course, we actually need to finish the question. We need the whole volume of the entire shape. So total volume is V1 plus V2. So we would get 829.4 millimeters cubed for that composite shape. So that's basically all of the shapes covered. Obviously with general prisms, you can work out the area of the base and then times it by the height. For pyramids, it's area 1/3 the area of the base times the height of the pyramid. And then spheres have the other formula, 4/3 times pi times the radius cubed. For most measurement tests or exams, they are on a formula sheet for you. So as long as you can identify the shape and then work out what formula you need, and then of course substitute in the right values, you should be able to get the right answer.